Introduction. Hello everyone, welcome back to the channel. In today's lecture, we're going to explore one of the most important pillars of modern cybersecurity, IDPS, intrusion detection and prevention systems. By the end of this session, you will understand why IDPS is needed, how IDPS architecture works, different types of IDPS, how threats are detected, real-world scenarios, best practices. So grab your notes and let's begin. Section 1. Foundations. What is IDPS and why we need it? Let's start with the basics. Every single day, more than 2,200 cyber attacks happen around the world. The average cost of a data breach is around $4.45 million. And here's the most shocking part. 95% of breaches happen because of human mistakes. This tells us one thing. Traditional firewalls are no longer enough. A firewall only checks who is entering the network. But we also need something to analyze what they are doing once they're inside. That's where IDPS comes in. IDPS stands for Intrusion Detection and Prevention System. It monitors network and system activity to detect malicious behavior. And not only detect, it can block attacks in real time. Think of it like this. A firewall is the security guard at the gate. IDPS is the CTV system that monitors everything happening inside the building. IDPS can identify, attack suspicious patterns, malware behavior, anomalies, protocol violations, and it reacts instantly. Section 2. Architecture. Core components of IDPS. Now let's understand how IDPS works internally. 1. Sensors or agents. These are placed at important points in the network. They collect traffic and perform initial analysis. 2. Management server. This is the brain of IDPS. It receives data from sensors and makes decisions using correlation rules. 3. Database. All logs, detected attacks, signatures, and historical data are stored here. 4. Console. This is what administrators use to monitor attacks in real time and configure policies. Example: if a suspicious packet enters your network, sensor sees it, management server analyzes it, database compares it with the known threats, console alerts the security team. This is how everything works together seamlessly. Section 3. IDPS deployment. Inline, passive, hybrid. Deployment is important because it defines how IDPS interacts with traffic. Inline deployment. All traffic passes through the IDPS. If it detects something harmful, it immediately blocks it. Pros: real-time blocking. Cons: can become a single point of failure. Passive deployment. IDPS sees only a copy of traffic. It can detect but cannot block automatically. Pros: no performance impact. Cons: only alerts, cannot stop the attack. Hybrid deployment combines inline for critical systems and passive for broader monitoring. Real-world example: banks use inline for ATM networks but passive for normal office traffic. Section 4. Types of IDPS. IDPS comes in 4 main types. 1. Network-based IDPS, NIDPS, placed at network boundaries to inspect packet flows. Detects port scanning, DDoS malware communication protocol violations. Example: if someone tries to scan all your ports, NIDPS detects the pattern and alerts immediately. 2. Host-based IDPS, HIDPS, installed on individual computers, servers, or endpoints. Monitors, file changes, registry changes, system calls, log files. Example: if ransomware starts encrypting files rapidly, IDPS detects this unusual behavior and stops the process. 3. Wireless IDPS, WWEPS, protects Wi-Fi networks and monitors RF spectrum. Detects rogue access points, evil twin attacks. Wireless DOS example: if someone creates a fake Wi-Fi hotspot named Office Free Wi-Fi, IDPS instantly detects it. 4. Network behavior analysis, NBA, uses machine learning to understand what is normal and detect anomalies. Detects data exfiltration, unusual logins, malware beaconing, zero-day attacks. Example: if your server usually sends 50 gigabytes per week, but suddenly sends 2 terabytes in 3 hours, NBA raises a strong alert. Section 5. Detection methods, signature, anomaly, and stateful protocol. IDPS detects attacks using 3 major methods. 1. Signature-based detection. This compares incoming traffic with a database of known attack signatures, just like antivirus. Pros. Very accurate fastcons cannot detect zero-day attacks. Example. If an attacker uses a known SQL injection pattern, IDPS blocks it instantly. 2. Anomaly-based detection learns normal behavior and detects deviations. Pros. Detects unknown attacks, detects insider threats. Cons. High false positives. Example. If the CEO logs in at 3 a.m. from a country he never visits, alert is generated. 3. Stateful protocol analysis. Understands protocol rules and checks if communication follows those rules. Pros. Detects advanced protocol misuse. Example. A TCP data packet received without a proper example. A TCP data packet received without a proper handshake, IDPS blocks it. Section 6. Real-world scenario. Blocking SQL injection. Let's take a real example, how IDPS blocks SQL injection. 1. Attacker submits a malicious query. 2. NIDPS inspects the packet. 3. Signature engine detects SQL injection pattern. 4. IPS instantly drops the packet. 5. Log and alert are generated. This prevents data theft and protects the database. Section 7. Challenges and best practices. IDPS is powerful, but it also has challenges. Challenges, false positives. Encrypted traffic cannot be inspected, can introduce latency, requires tuning. Best practices, use layered defense, firewall plus I, DPS plus W, AF. Update signatures, frequently tune the baseline regularly, monitor logs actively. Security is not a one-time setup. It is continuous improvement. Conclusion. To summarize, IDPS is essential for modern security. It detects and prevents cyber attacks.